All right, good morning, calculus students at TAS. So this is Mr. Mek, and obviously today I'm not here at the school. I'm in Thailand, taking care of a visa issue here. But anyhow, this is the recorded or pre-recorded lesson for you guys, so that you can watch this video and take notes. Today is Wednesday, August 31st, 2022. This would be your period 2 for today, B day, for calculus students. Now, you guys have some stuff that I gave you from last time, trigonometry packet. And if you did not finish that, please start with that. And then today, whatever I would explain or teach to you in this video, you can take notes. And then once you take notes, then you follow my instructions, what to do next. So just watch the whole video and you know what to do. Okay, let's begin then. So first order of business is to take care of your last set of problems. So I do want to remind you for you guys to finish those problems for the trigonometry, the first stuff I gave you. And not the unit circle, but let's talk about the assignment that I gave you from before. So I believe you should have finished this stuff already. This is a 3D trig problem. We did that in class, I think. You should be able to convert all of these into radians and degrees using these equations that I gave you before. So that part was from last time. Then there was a tangent homework that you guys were working on, I believe. And so you should have been able to do these problems as well. Okay, remember there is more than one answer for all of these. And use your unit circle. So you have your unit circle that I gave you to help you, right? So you always start 0 here and just double check what your sine, cosine, tangent values are. But remember, you have to do 2 answers for most problems because you have the whole unit circle takes up quadrant 1, quadrant 2, 3, and 4. Correct? So wherever you have a tangent, if you have a positive number for tangent, it's in quadrant 1 or in quadrant 3 as well. Okay? Those are the quadrant 1 and 3 is where you have a positive tangent. If you have a negative tangent, it would be quadrant 2 and quadrant 4. And same thing with the sines and cosines. Sine is positive in quadrant 1, and in quadrant 2 is positive. But in quadrant 3 and quadrant 4, the sign is negative. And cosine would be, of course, positive in quadrant 1 and in quadrant 4. And cosine is negative in quadrant 2 and quadrant 3. So just keep that in mind as you do that. So today's new assignment you have is going to be this one. This should have been given to you in class in the handout. So this is the one that I forgot to give you last time. So you're doing it today. It's for sine functions and cosine functions. Similar to your tangent homework, you basically have to give like 2 answers. Now, if you want to visualize this, because I want you to draw the sine and cosine wave graphs. So what I want you to do is I want you to draw it like this, and I'll show you the website where you can. This is not going to give you any wave function. This just shows you the right triangles and how they fit in the unit circle. But what will really help you is this. So this one is the website address. I'll send it on the Google Classroom later so that you can use this because it's a very good website. Okay, so let's look at this unit circle again for our trigonometry. But now you see the actual wave function of the sine function or the wave of the sine function, okay? So we'll start over here. We'll start with 0 degrees. So we're starting at the origin here, of this graph, okay? And then watch me move along. See, now we're moving the unit circle. You see? Now I'm creating my right triangles, or any triangle in the unit circle in quadrant 1. And notice how it's going in the unit circle and also on the wave of the sine. along the curve of the sine wave. Okay, so, and these are the exact values that you get, remember? Now, of course, this wave graph shows the radians, right? This is like pi over 4, this is like pi over 2, this is pi, but this is pi over 2, you know, is 90 degrees. Pi, you know, is 180 degrees, right? Pi over 4, you know, is like 45 degrees. So you can equate everything in both degrees and radians. That's the beauty of this little website. So this should not be a problem for you to use to solve your problems on this worksheet. Okay, so always refer to this. So anyways, you do that, and then you can go to quadrant 2, and they keep showing the right triangles in all the quadrants and how and where they fall on the graph of your sine wave, your sine function. And then you get to 180 degrees. Now you're in quadrant 3, right? And then now you're like at the bottom part of the sine wave, and you hit the 270 degrees, and then you go back up the curve again in quadrant 4, and there's the last set of right triangles, and then you go full rotation, right? 2 pi or 360 degrees, but you can keep going from there, and then you would just repeat yourself again, right? It would just be an exact identical part of the sine wave curve going on. Got it? So that is for the sine function. For the cosine function, you do the same thing here, but it's exactly the very similar wave, but you start at a different position for the cosine. For the cosine, okay, for the cosine function, instead of starting, when you're at 0 degrees, instead of starting at like, 0, okay, you start at the value 1. Remember, in the unit circle, every radius of the circle is 1, right? And that includes the hypotenuse of your triangles, or right triangles. So anyways, we start at 0 degrees. Let's go up. Now we're just going down that curve of this cosine function or cosine wave. Okay, and then you can see everything in radians and also degrees, just like we did with the sine function. Okay, just keep going. Quadrant 2 now. Quadrant 3. Quadrant 4. And we go 2 pi, 360 degrees, and we completed the unit circle. Understood? And then we just repeat over and over again. So the cosine and sine waves are very identical to each other. They're just shifted, right? So the sine here would have started at 0, and then the cosine here started at 1 when you're at 0 degrees for both. So when you do this set of problems for the sine and cosine, okay, I want you to draw those graphs here. Understand? You don't need to use your calculator. You can use that website that I gave you. Understood? So, and make sure that you stay within the unit circle of 360 degrees for the full circle revolution. Now, don't just draw me the waves, but I want you to also solve the values. So when you solve for x here, be mindful, remember that you can have 2 values. So going back to that website, when I'm looking at my sine, wherever I have 0.3, right? Oh, sorry, let me go back here. Wherever sine is 0.3, right? You have this one in quadrant 1, and then you also have in quadrant 2 as well, where you have sine is 0.3, more or less. But you can decide what the angles would be. One angle would be here, and then it's a smaller triangle. The other angle, it would be in this quadrant 2, right? But be mindful of what right triangle that actually is. Don't give me like 160 something degrees. Well, you could give me that. That's fine. Give me that as well as the other one. But that's not quite there yet. I think you have to maybe estimate a little bit more. Maybe that is the correct answer. I'm not sure. But yeah, I mean, or if you don't want to use your unit circle, you could just take 180 degrees minus whatever degrees you have here to get the exact, angle that you're looking for here, okay? So because it's going to be whatever small right triangle you start with quadrant 1, but you also have that same right triangle in quadrant 2, But to get the exact degrees of that is 180 minus that right triangle's degrees. Make sense? So what I'm saying is if to get sine of something to be 0.3, right? 0.3 value or whatever, like somewhere around there. Like if it's 17 or 18 degrees, that's the right triangle where you get the first value of 0.3. But then if you want to get it in quadrant 2, right? It's the same angle here, like it's some kind of a 17 or 18 degree right triangle in quadrant 2 here. But to get the exact degree, it's 180 degrees minus that. Understood? Okay, and now for the cosine, you can do the same thing. Okay, whatever triangles you make in here, be mindful of that. So if the cosine is supposed to be a positive number, it will be positive in quadrant 1 and also in quadrant 4 again. But there will be the similar same right triangle. Understood? And so you just basically take 360 minus that right triangle to get the right triangle or to get the actual degrees of it in the quadrant 4 down here. Okay. Anyways, you figure it out. Just use your unit circle and this website to help you. You can also go back and use our original unit circle website here. This is fine as well. Okay. You don't have to use, you can use whatever you want, or your graphing calculator if you want to be brave. So that's how you're going to do this assignment here. All right. So drawings and then solve for the x values of these problems. Okay. So now from last time, you should have finished the tangent and the 3D stuff. And then I want you to today, after you're done with the sine and cosine stuff, please, at the Google Classroom, right, you have a new posted assignment that you can submit online here. I forgot to give you a sheet of it, so I'm having you do it here online. So you can submit it on the Google Classroom here. So it's a trigonometric table review task. Once you click on it, you may download it and then you can do it on paper and then upload it again. But that assignment will look like this. Understood? So you will have these problems to do. You're doing like from number 19 to number 36. Understood? So these are all just the special 3 right triangles. The 30 degree, 45 degree, the 60 degree right triangles that we did, right? I gave you all these actual lengths, height and base. All the hypotenuse will be 1 anyways, right? But then they all have their, set fixed value for their height and base, remember? So look back at those notes I gave you, and you should be able to solve all of these if I did not give you the sheet before. But please submit it on the Google Classroom here. And then once you're done with that, you may do your reading assignment. So this will be the last thing for you to do. Your reading assignment is go to the textbook here. Okay, this is your calculus textbook. All I want you to do is read section 1.1, functions and the graphs. Understood? Please just read that. You can also read section 1.3, trigonometric function as well. Heck, you can just read all these 3 sections over the weekend, over the long weekend. Understood? But you can start reading that in class today if you have time in this second period session. So I hope I have now made the objective of today's lesson clear. And so I should see you guys next week. I'll be back. I think on Monday, it's going to be a day again. So I'll see you again on Tuesday. I'll be back hopefully in Vietnam by then. So have a great weekend. Have a safe weekend, you all. And good luck on this assignment or assignments, right? So have a great day. Goodbye.